Purna?
Sir.
Hello, Purna.
Sir.
Introduction start.
Sir, can we start, sir? Sir. Hello, sir. Okay, sir. Just అదే సార్ 10 మెంబర్స్ ఉన్నారు అందుకని వెయిట్ చేయండి. ఓకే సార్, నేను స్టార్ట్ చేస్తాను సార్. ఓకే సార్, ఓకే సార్, ఓకే సార్, ఓకే సార్, ఓకే సార్. Good afternoon, everyone. I consider it an honor to present the profile of our guest speaker, Dr. Sridhar Kandor. As a distinguished professor with over 28 years of experience, specializes in design innovation, technology entrepreneurship, applied research, and product design. Currently serving as the chair of aerospace and mechanical engineering at St. Louis University. Dr. Sridhar Kandor is the author of multiple books, including Innovative Conceptual Design, and holds patents such as the hubless wind turbine. He has designed cutting-edge courses in CAD, mechatronics, robotics, and design thinking, integrating activity-based learning to foster entrepreneurial mindsets among the students. A passionate educator and leader, he has organized numerous workshops and contributed to industry academia collaboration. As a chair of ASME St. Louis section with a PhD in mechanical engineering from Texas AM University and degrees from IIT Bombay and JNTU, he remains committed to shaping the next generation of innovators and entrepreneurs. We welcome you once again, sir. Thank you.
Good afternoon to you all.
Sir, good afternoon, sir.
I hope you are having a wonderful workshop. It's my pleasure to kind of talk to you today. As you can see, my profile is much more on the entrepreneurship side of it. So I want to share some information that shows the big picture. And actually, we made a presentation. Some reason that file got corrupted. So I'm going to do a simpler version, but I would provide the entire version later. Okay. So let's see whether I can go back. Can you see? Can you see my slides? Can people see my slides? Yes, sir. Okay, that's good. Okay. So if you have to guess, when do you think the electric car movement started? 1980s, 90s, 2000, 2010, 2020? Any thoughts? Unfortunately, I can't see the text messages, so if you can unmute your mic and tell, that would be good. do I see? Text messages. No text message. Okay. So let's kind of look back and say things that happened in India abroad in random order. Actually, it was supposed to be a game, but because I told you the file got corrupted, we are just running through the thing. So if you think about India, which city do you think introduced electric buses in public transportation for the first time? Can anyone answer that question? Bangalore happened to be the first city that introduced electric buses. They did it almost 20 years ago. But the problem was the cost was really high, about 3 crores per bus. That's equivalent to buying 3 Volvo buses or more. Okay. They did not get a good battery life. The range was limited to about 250 kilometers, and the charging time was 4 to 6 hours. Okay, so these buses were pretty unpredictable. So people had trouble when the buses stopped because of they ran out of charge. So happened to be the Bangalore would be the city that you should think about when you say first city to introduce or think about electric buses. Okay. Somebody can yes, that would be great. It's 43 times. So the city you can think about is Bangalore. Again, a lot of these things, new things when you try to do, they would be automatically failure. But we kind of learn one of the big factors tend to be the battery life and the time it lasts. So in 1990, slight shade. Stop shade. I'll stop sharing one time. This happened earlier also. Start.
Visual circuit. Okay, sir.
You can see the slide. Okay. What was the name of the electric vehicle developed in India in 1990s? So people think about cars, scooters, buses, but the first electric vehicle developed was Vikram Sefa, which is a auto three-wheeler. Okay. Think about first fully electric car in India. It is Reva, Revolutionary Electric Vehicle Alternative. This is became part of Mahindra and Mahindra, and they were using lead acid batteries. And the range was about 80 kilometers on a full charge. Okay. So let's kind of shift from India worldwide. So there are a couple of major cars, the electric cars came. One was General Motors EV1, which was not a big success. Then came another car that came in 2010. Okay, that's not Tesla, but it was pretty nice one. If anybody wants to make a guess, feel free to guess. It would be much more interactive if people talk. Otherwise, it would be one way, one directional thing. If you want, you can text in your WhatsApp group. No, I'm not in the WhatsApp. Okay. So the first one that became really somewhat popular, successful was Nissan Leaf. Nissan Leaf, the main advantage was it's fairly affordable. It was one of the first cars to use lithium-ion battery. It has about 70 miles range. These not kilometers, I'm talking in miles range. And when Nissan came up with this battery, they started thinking about how do we recycle the battery, and they actually put processes in place to recycle the battery. I'm going to play the advertisement for Nissan Leaf. It's kind of thing because one of the things that people do when you bring a new product is you have to educate the customers, help them to buy the new products. In terms of cost, electric vehicles are expensive. In terms of range, it has less range. So how do we sell to people who don't see the performance value in the electric vehicle in the initial stages? So Nissan Leaf decided to adopt a strategy to appeal to the core values. So they made this advertisement.
The 100% electric Nissan Leaf. Innovation for the planet. Innovation for all.
What they're telling you, buy this car because it would be helpful for the planet. So they're trying to address your core aspirations, green people, things like that. And it was had, even though it has a limited range, a lot of people in the United States, particularly states where this tax incentive regulation, like California, a lot of people bought Nissan Leaf. It changed the perception of electric vehicles in United States. So if you think about the vehicle, a fleet where they started using electric cars as a taxi service. Okay, which is the city in United States. People think about California. People think about maybe Washington D.C., but the first one is New York City. They had a fleet of electric vehicles. Anybody can guess which year? Somebody put a text message. Let me see what that. So it was 1890. New York City started this because it's quiet, it's clean, easy to drive. You think about clean. What do we mean by clean? In those days, there was about 15,000 horses were going around in New York City. So imagine the amount of animal waste that comes onto the street, and they have to clean all those things. So electric cars were pretty good. So Electrobat was the car that they were using. It's about 2,500 pounds. If you really think about it, more than 100 years ago, it was 2,500. Even now, the electric cars are about 1,500 pounds. So we didn't drop in the weight significantly. So 100 years, 1,000 pounds is what the drop is. Okay. They were using lead acid battery. Flip side of it is the mileage is 15 miles per hour they were going, and the range about 25 miles. That's the range is good. So here is it, even though it says 1800, they really mean 1890, closer to 1900. This is the electric field. Okay, this disappeared because there are three major things happened. One is the company was fudging the financials, so there was a financial problem much faster than they could financially sustain, and there were fire that burnt off some of these cars. Okay, that same time Ford Model T came 1907, and that took off the electric engine. So before internal combustion engines, it was electric engines. So there was a transition between electric to internal combustion engines in 1900s, and we are transitioning back to electric in 2000s. Let's think about some numbers. Okay, I think my main purpose is for you to see the big picture and see how this research or applied work is changing the people. So if you think about transportation energy across the world, about 14 to 16% of energy is consumed by the transportation sector. In India, it's about 18 to 28%. So in India, we spend more energy on transportation than worldwide. There could be a couple of problems. One is roads infrastructure may be underdeveloped. Other part of it is the colder climates, you may spend more energy in terms of heating homes and things like that. So if you take this 18 to 20% of it, the roads, that means cars, lorries, buses, all of them consume 70 to 75% of electricity, the energy. Okay, rail, ship, and aviation consume the remaining 25 to 30%. So why we are interested in development of electric vehicles, that is cars, buses, and things like that, is because lot of energy consumption is locked up on the roadside than rail, shipping, or aviation. Okay. So why is this important? Right now, we are heavily reliant on oil imports. So anything that relieves the burden makes it better for India. Second part of it is environmental concerns. So we see smog, dust, and carbon dioxide, carbon monoxide, and all these gases everywhere, apart from sound pollution. Okay, electric vehicles are quiet, so sound pollution should be lesser, and also air pollution would also be lesser. Okay. So if you take an electric car itself, and you want to think about what percentage of the electric car uses the energy in terms of propulsion and how much of it is wasted. The electric car is very, very efficient. 80 to 90% of energy is dedicated to propulsion. The reason why is the energy conversion efficiency is high, and also regenerative braking. So when you brake, the energy comes back to the battery. So whereas IC engine, the energy does not come back to the battery. So the traditional IC engine is 12 to 30% depending on how you. So in terms of energy usage, electric engine is very efficient. If you take IC engine, typically a car may have 100 to 150 horsepower. If you are going at a steady speed on a highway, you need about 30 horsepower. So you are taking a 150 horsepower engine and running at 30 horsepower. So that's where inefficiency comes in an internal combustion engine. Okay. So cost-wise, where is how much do we think battery packs cost? If you think about battery packs, they are the most expensive piece. 30 to 50% of the car cost is locked up in the battery. So let's take the Tesla. Tesla would come closer to 30% because the scale of operation. So what determines the cost is one, scale of operation. The second determinant of the cost is how easy to acquire the raw material. Tesla manufactures batteries and stuff like that in China, and the cost is less. One of the reasons is the Indian batteries come around 45% of the cost is locked up in the battery. So we are on the higher side. So if you think about different types of battery, lithium ion, phosphate, metal, nickel, all of them, you can see the cost anywhere from 5,000 to 20,000. So you can see solid state batteries to be very expensive, but they are the new thing coming in, and we should see them probably in the few years ahead, next 4 to 6 years, in most of the several cars. The biggest advantage is the lifespan. The lifespan is 15 to 20 years compared to lithium ion, which is more like 8 years. Okay. Again, the environmental conditions play a significant role on the lifespan. People ask what level 1, level 2, level 3 EV charges. Most of you may be electronic band, so you should be able to tell, but typically level 1 is 120 volt overnight charging, 8 hours, 6 to 8 hours. Level 2 is 240 volts. It's faster. I'm not sure in India whether you are doing level 1 or level 2. Level 3 is fast charges. That's all. Now Tesla is working for the next generation of supercharger network. They are working with a lot of manufacturers to create this one. So a 5-minute charge would get you 75 miles. So you stop at a gas station or an electric charge station and charge for 5 minutes, it should get you 75 miles. That's more than 100 kilometers. That's essentially the near-term target they are working with. And once that comes, things would be much faster. So the two important things that drive people to buy internal combustion engine is, one, how easy to put a large amount of energy into the car very quickly. So the energy density of petrol is very high. That's why we are able to fill in some 10 liters and it goes for a very long time. Okay. Whereas electric charge, putting energy is not that easy. It is very time consuming. So in 2040, if you think what percentage of electric vehicles would be in India, people have their own guesses, but somewhere people say about 30% of the energy would be vehicles would be electric. Let's say less than world average. World is looking at about 50%, and particularly this is important because it reduces pollution, increases. So let's kind of focus on sustainability part of it. The main thing about electric vehicles people talk about is sustainability. So what emissions do EVs help to reduce most? Okay, it reduces carbon monoxide, methane, all of them, but the most important one is carbon dioxide. So the emissions is 50 to 70% less carbon dioxide compared to internal combustion engine over the lifespan. Okay, uh, but this number 50 to 70 seem to be wide. Why so wide? Because the cars are getting charged from the grid. The grid may have renewable energy like wind, solar, things like that. If the grid has a good mix of renewable energy, then it would be saving a lot more carbon dioxide. That would be closer to 70%. If the grid is completely coal, then it would be much closer to 50%. So, depending on the location, your grid may have a different energy mix, and that energy mix influences how much carbon dioxide is saved. So this is a bad thing. I mean, that's a good thing. What's a bad thing? What is the biggest environmental concern? Why do you think we should not use CV? If somebody is arguing, what would be the case? The biggest case is mining of most material, particularly lithium, cobalt, magnesium, nickel. These four are really causing big problem in terms of destruction of habitat, water pollution, and other things. So this is the single biggest concern with environment. The second one, which I haven't listed, it was there in the original slide, is disposal of these batteries. We haven't really figured out how to efficiently, in scale of large number of batteries coming in, how do we dispose them? We are able to make it and say 8 years from now we'll figure it out because lifespan is 8 years, but 8 years will come much faster than we think. So we really need to work on what is the efficient way to dispose of these batteries. Okay? So let's think about why we use them, where it is produced, and key environmental impact. Think about lithium. The biggest advantage is it helps you in the energy storage, high energy density, pretty lightweight. Okay, it comes from Australia, Chile, Argentina, Bolivia, and China. So that's where we are procuring our raw material. Problems is it's creating water scarcity, land get degraded, and there's a pollution at the source where they're mining happening, and pollution happening at processing plants also. Okay. Cobalt is used to stabilize cathode. Okay. It extends the battery life, improves energy density. So it's pretty important. And it's procured from Congo. Child labor is a big problem in Congo. Russia, Australia. Australia may be friendly. Russia is also friendly to India, but you never know. There's a toxic waste, habitat destruction, and the human rights concerns, particularly child labor in Congo is a big problem. Nickel has also increases energy density, but other impact nickel has is increasing the life. Again, the sources are Indonesia, Philippines, Russia, Canada. Okay. Problem is some of these places, Indonesia, Philippines, there's a deforestation happening, air water pollution, and there's a runoff from the mining causing marine life damage. Magnesium helps in battery stability, prevents overheating. Done in China again, South Africa, mining related deforestation, toxic waste production. Okay. You see, the country that is a lot of times missing is India. So we are relying on China and other countries to supply these key elements for making these batteries. And that's a big problem uh, in terms of national security. We are singularly dependent. So we need to do two things. One is find alternatives for these materials. The second is how do we use these materials efficiently so that we can recycle, repurpose these things as they age. So why do a lot of research is focused on cathode? Okay? Why do we want to do cathode? Is cathode has most expensive, most important, and most pollution happens because of cathode. So if you think about cathode material, if you take the car cost, 50%, 30 to 50% is battery cost. And if you take the battery cost, 40 to 50%, half of it is cathode cost. Okay. So if you change cathode, you could drop the price of the battery pack. Okay. It's critical because it determines energy density. It tells you what the performance is, and it also tells the stability of battery. A lot of these materials we talked about, cobalt, nickel, lithium, all of them, cathode materials, have fairly significant environmental consequences. So a lot of research is being done in the cathode side of it. And think about future. How would the future look like? Okay. The future, people are thinking about how do we get out of internal combustion engines. If you think about cities, they are planning on, some cities are very forward looking. One of the forward looking cities said by 2030, 100% of public transportation is electric. The city is Pune. Okay. Pune was the one who introduced the city waste. They took it and created the gas powered city buses. So the slogan was city waste to city bus. So you would see a lot more public transportation, electric. And I think there are buses, electric buses running between Bangalore and where I am in Chittoor. We may see a lot more of vehicle to grid technology. And this is more expensive to build. And India may be on its way to build this sooner or later. Okay. The advantage of it is it fills the gap in renewable energy. Wind doesn't blow all the time. Okay, so if it is nighttime, sun is not there. Wind doesn't blow all the time. So you need to figure out how to fill these gaps when they do blow and when they don't blow. So all these cars with batteries essentially act as mobile storages, and they can power the grid when the grid needs it and take it back. So it will become bidirectional, with energy coming into the car when you need it, and when peak time, when everybody is at home in the evening, lights are on, or peak time in summer where everybody is running air conditioning, the cars can actually supply energy to the grid. And that would be vehicle to grid technology. Is something a lot of people are working on, smart grids and things like that, particularly that comes to your field. Solid state technology. The biggest advantage with solid state technology is energy density. So solid state batteries have 2 to 3 times the capacity of a lithium ion battery. So the biggest problem is overcoming the manufacturing cost. The cost of making solid state batteries are still extremely high, and scalability. Making few in a lab is easy. Making lakhs of these battery packs is the difficult part of it. Okay. So those are the two barriers we need to overcome if you want to see solid state technology in cars. So we are thinking about next generation cars. Now we talked about 100 miles, 300 miles. So what's the next step? We are looking at 500 to 1,000 kilometers per charge is what people are doing. In India, the goals are more modest, which is 400 to 600 kilometers. One of the reason is not just there's always a compromise in a designer's mind in terms of the cost and range. We don't travel that much in a day. Most of the time, you may be traveling maybe 100 kilometers a day or 200 kilometers a day. So why put 1,000 kilometers in a day? You won't travel. So you will have charge. So the amount battery pack size decreases significantly. But the important thing why this is important range is because there's anxiety in people when they are buying electric cars that, hey, I can't go long distance. Okay? And that is becoming a big barrier for electric vehicle adoption. So by removing it, we can basically travel longer distance. Okay? And people are more likely to accept it. Okay? So let's kind of talk about how we see the evolution of this trajectory of electric vehicles. Where do we see these electric vehicles? Okay, I put it there, and this is the kind of last slide, and I hope we can have some interaction after this. So there's hybrid, there's electric, autonomous, hydrogen. For India, a lot of times hybrid may be really good initial starting point than electric vehicles. Why hybrid? The advantage of hybrid is you do not need electric infrastructure of charging stations all over the city. You can, in a hybrid car, the petrol powers the battery pack and reverse happens. So hybrid would be a good choice. So you don't need to charge it. If you want, the next step could be a plug-in hybrid. Okay. Then electric cars come. With the electric cars, we really need to focus on the charging infrastructure. Small scale, switching the battery pack is one option people are considering for particularly autos and things like that. If you remember what I talked about, New York City, the taxi fleet, they perfected to swap the battery in less than 2 minutes. Okay, that's what. So the idea of battery pack swapping, people think it's new. It is more than 150-year-old or 130-year-old idea we are redoing. Electric car, what it enables, which did not happen with internal combustion engine, is autonomy. Okay, autonomous cars are becoming uh, reality. If you go to some cities in US, you can go into autonomous car cab and they take you from place A to place B, and there's no driver, no interaction. You sit there and it autonomously drive. Okay, the autonomous cars couldn't have worked with internal combustion engine, whereas electric car is a natural mix because the electric energy, it's easier to control electric motor. IC engine is much more difficult to control, and the sensors and the whole pack is there. Okay. Between electric and autonomous, there are few advantages, both of them. Um, a the current infrastructure in terms of gas stations are going to disappear. Current infrastructure in terms of car maintenance, you don't need that kind of maintenance. You don't need to change your brake fluid or cooling fluid, nothing like that. So there are going to be changes there. Okay, and they are quieter, easier to drive, and in an autonomous car you don't even need to drive. But as you go through autonomous car, a lot of issues come, like liability. If something happens, who is liable? Autonomous cars also provide the ability to download the new version, and you can do a hardware upgrade or a software upgrade. But autonomous cars, the biggest disadvantage, both autonomous and electric, is the life of the battery pack. Life of battery pack is 7 to 10 years. So if you compare it with the internal combustion engine, you still see cars which are 15-year-old, 20-year-old, you half of the cost of the car is locked up in the battery. In a electric car, it's not easy to swap batteries. Okay, so if we think about further down the future, we are looking at a hydrogen economy, and we basically have more hydrogen cars. In fact, the institution we are teaching, I'm teaching, we have started teaching a course on hydrogen as an alternative energy source. Okay, this is a 400 level course we are teaching to the students. So if you think hydrogen, electric, autonomous, all of them are options, and you would see this evolution. And earlier, things used to happen in a long scale. Now things are going to happen much faster in our lifetime, not somebody's lifetime. Okay, so you should be able to see these changes. So with this, I kind of stopped. Okay, let me kind of ask questions. Is there any question that I can answer?
Sir, good evening, sir.
Yeah.
So actually in India, the last 10 years back onwards, the problem is energy inflation problem.
Yeah.
That means energy shortages. Suppose in future coming for an electric vehicles, so
Yeah.
most probably it will happen during that alternative energy source, like a fossil fuels already depleted. So in
Yeah.
that point of view, you're talking about hybrid electric vehicle, most probably it will be suitable for India. But when I go for an hybrid electric vehicle, if you go for design specification as well as analysis and cost, is it satisfied for an economic factor, sir?
The hybrid cars are pretty economical.
The
Okay,
economic.
there are two parts of the economy. One part comes from electric vehicle. If you want to buy, the electric charging infrastructure is not there. So
Okay.
hybrid vehicle relieves you about the electric charging station. You don't need a charging station. You still fill your petrol and keep going. And the engine runs constantly, powers the battery and switches off. So it peaks the battery pack. So it is economical, and also works well with the Indian conditions now.
Okay, sir. Okay, thank you, sir.
Welcome. Others? So a lot of time we have this thing that whatever we are doing in electric cars is new, but why there are no widespread EVs in India? Recently, about loud convention more than LP. Is that true? Okay. I don't. Yeah, it's. So, two parts to the answer. First, I don't live in India, so I don't know the exact answer for it. But EVs are not widespread in India, in my view. The biggest problem is there are no charging stations outside your home. Not easy to charge. So if you have a charging station, let's say you are working at your college, you come in the morning, you can plug it in, and while going, it is fully charged. That would be good. Okay, and fast charging infrastructure. You see in US, you go to Walmart or some big store. There's always a charging station. The college I work, we go, when you park, there's a charging station. So charging stations are not there. And without charging station, you can't buy electric vehicle. That's why I was thinking of hybrid electric being a temporary alternative until the charging stations come up more. So you have to train you have to provide other facility too. Buying a EV car is part one. If you want to run it, you have to have a charging capability, and that charging capability is not there. So it kind of resembles the olden days typewriter they were selling, but nobody was using typewriters. Why? Because there were no typewriter institutes. people don't know how to type, so they don't buy because typing is very slow. But once they learn how to type, it's very fast. Same way, buying an electric car won't work unless you have charging stations all over the city. So you can think about how many charging stations are there from your home to your workplace. If you have other questions, please feel free to type in the chat or directly unmute and talk. As we are waiting for the thing, uh, almost there's no new idea in the world. All of them is reinvention of the thing, like battery pack. So electric vehicles is nothing new. It was there in 1890, and we are redoing the same thing again, but with better materials now, with better knowledge, lighter weight. But these materials, one side we are reducing carbon dioxide emission, other side these materials are polluting a lot. So we really need to figure out how to reduce the amount of material needed for battery. How do we recycle the battery? Recycle could be how do you take things apart, or how do you renew the battery or repurpose the battery. So you can take the battery, make modification, use it at home, things like that. We have to figure out alternative ways of using this. So a lot of research should be focused on the batteries, particularly the materials I've mentioned, four of them: cobalt, nickel, all of them are pretty. Other questions? If there are no other questions, we'll stop here. Thank you very much. I'll make the slides available. I'll update the slides and provide you through your workshop coordinator. Thank you. Have a wonderful evening.
సార్
లేదు ఇప్పుడు సార్
సార్
చెప్పాడు ఓట్ ఆఫ్ థ్యాంక్స్
yes sir. On behalf of Department of EEE SVCET, I would like to extend our sincere thanks to Dr. Sridhar Kandor for his engaging and insightful session on socio-economic factors in electric vehicle adoption. Dr. Kandor, your deep understanding of the socio-economic challenges and drivers influencing EV adoption has provided us with valuable insights. Your presentation has broadened our perspective on the factors beyond technology that play a crucial role in shaping the future of electric mobility. We truly appreciate the time and effort you invested in this session. Your expertise has made a significant impact, and we look forward to future opportunities to learn from you. Once again, thank you, Dr. Sridhar Kandor. Thank you, sir. అవును సార్, అవును సార్, అవును సార్. 6:30 to 7. ఫీడ్బ్యాక్ ఒక ఇచ్చారు సార్, 1 అవర్ ఇచ్చారు. లాస్ట్ ది వ్యాలిడేట్ ఇచ్చారు.